Glenn-Colusa Irrigation District, also known as GCID or the District, has had Sacramento River water rights since 1883 and was one of the first large-scale water users within the Sacramento Valley. With more than 140,000 acres of productive and valuable agricultural land, GCID continues its tradition as a large-scale water purveyor, maintaining the largest irrigation district within the valley. The Sacramento River serves as the principal water source for the district. Its diversion, the largest surface water diversion on the river, is located at the northern end of the district, approximately 100 miles north of the city of Sacramento. GCID maintains year-round service to convey water during the irrigation season, as well as to customers requiring water in the fall and winter months, including neighboring wildlife refuges. GCID delivers water to 20,000 acres of critical wildlife habitat comprising the Sacramento, Delavan, and Colusa National Wildlife Refuges. The surface area's main facilities include a 3,000 cubic foot per second pumping plant and fish screen structure, a 65-mile main canal, and approximately 900 miles of lateral canals and drains. The pump station is situated on an oxbow off the main stem of the Sacramento River. Water flow passes through the fish screens where a portion of it is pumped into GCID's main irrigation canal. The remaining flow in the oxbow passes by the screens and then back into the main stem of the Sacramento River. A major flood in January 1970 significantly changed the shape and flow of the Sacramento River downstream of the GCID intake channel. Approximately 4 miles north of Hamilton City, a meander was cut off, which reduced the river reach by approximately 2.5 miles. The riverbed gradient within this reach continued to degrade with seasonal flood events, lowering water surface elevations by 3 feet at the GCID diversion, leaving much of the screen out of water. GCID's peak demand generally occurs in the spring, often at the same time as the peak outmigration of juvenile salmon. 4 runs of Chinook salmon, fall, late fall, winter, and spring, inhabit the Sacramento River. In general, all 4 runs have declined over the past 25 years. One reason for the decline was the lack of fish screens, or, in the case of GCID, poor performance of an existing 20-year-old drum screen. The district's diversion was identified as a significant impediment to the downstream migration of juvenile salmon as the lower water surface elevations contributed to unacceptable fish losses at the existing drum screen facility. Following the state and federal listing of the winter run Chinook salmon as endangered through the Endangered Species Act, pumping restrictions were imposed on GCID by a court-ordered injunction in the early 1990s. Preventing the district from diverting its full water entitlement until a long-term solution was implemented. Helping fish past GCID's pumping facilities has been a major challenge in sustaining this important agricultural area. An interim flat plate screen was installed in front of the existing 480-foot-long drum screens in August 1993. Biological monitoring of the interim measures amply demonstrated that the flat plate screen is a viable method of ensuring long-term fish protection in the Sacramento River. In cooperation with various resource and lead agencies, GCID and its consultants helped to develop a long-term solution to meet 3 major objectives: to provide safe fish passage past the GCID diversion facilities, ensure a reliable water supply to GCID by allowing the district to divert their maximum capacity 3,000 cubic feet per second, and provide for long-term fishery protection of up to 50 years. The GCID Fish Screen Improvement Project was created as a long-term solution to the fish passage difficulties at the GCID diversion. The design of the long-term screening solution was based, in part, on the interim measures implemented by GCID with assistance from the U.S. Bureau of Reclamation, USBR. A cooperative effort involving GCID and the resource agencies resulted in the construction of a state-of-the-art fish screening facility at the GCID pump station. Several components were integrated into this project to meet the needs of the fisheries and the physical requirements for diverting water. The major components included channel modifications, a water control structure, improvements to the existing interim fish screen, a 620-foot fish screen extension, 3 bypass pipes, and a gradient restoration facility. Reclamation designed and provided construction management for the screen extension portion of the project, with some components of the project designed in cooperation with GCID consultants. The U.S. Army Corps of Engineers, USACE, was the lead agency for the design and construction of the gradient facility, or riffle, in the Sacramento River. GCID performed necessary modifications to the intake and bypass channels to pass fish more efficiently by the screen facilities and incorporate the water control structure. The water control structure, a component of the fish screen extension package, resembles a long-throated flume and was needed to operate the gravity-piped bypass structure. Its adjustable concrete weir blocks are used to set crest height to balance hydraulics between the main Sacramento River channel, the intake channel, the screen face, and the bypass channel flows. This structure establishes backwater elevations to ensure that the screens are completely submerged and flows past the structure meet resource agency criteria for protecting the fish. The structure was constructed in the dry using a cofferdam configuration, and flow through the oxbow was maintained by diverting water in a bypass around the cofferdam. The 620-foot fish screen extension has 45 screen panels, is approximately 29 feet deep, and brings the total of the entire structure up to an impressive length of 1,100 feet. This structure was also constructed in the dry. A cofferdam was installed and then dewatered for optimal construction conditions. There is almost 12,000 square feet of screen area, allowing GCID to divert its maximum capacity when necessary and still meet agency fishery requirements by permitting no more than 1/3 foot per second flow velocity through the screens themselves. Screen slots on the fish screen extension are no larger than 1.75 millimeters. That's smaller than the diameter of a BB. To maintain proper uniform hydraulics over the length of the screen, a flow baffling system and cleaning system were installed. A cleaning system sweeps the screen panels continuously while the district is diverting water to keep the screen free of debris and possible organic growth. An internal bypass system was designed to enhance fish passage along the screening structure. The amount of time that a fish is exposed to the face of the screen is referred to as exposure time. Resource agency requirements at GCID permit a maximum fish exposure time of 2 minutes. To move fish past the screen in under 2 minutes required 3 54-inch diameter bypass pipes spaced evenly down the length of the screen to allow tired or stressed fish to enter the pipes and circumvent the structure. The Central Valley Project Improvement Act authorized the fish screen extension component of the project. This component totaled $50 million, which included planning, design, environmental documentation, construction, mitigation, and testing and monitoring. The cost was split between participating agencies, 75% by USBR, with the remaining 25% shared evenly between the state and GCID. To restore the hydraulic gradient, which was continuing to erode after the 1970 flood, and ensure a stable river level for efficient screen operation, USACE and its consultants designed and constructed a gradient facility, or riffle, in the Sacramento River. The major objective of the gradient facility was to restore the river elevation at the mouth of the bypass channel to its pre-1970 water elevation so there was enough available head to operate the screen's pipe bypass system. The gradient facility now stabilizes the riverbed to provide the required water surface elevation at the fish screen. It also facilitates safe and effective fish passage by providing adequate flow velocity past the screen, as well as flow conditions that enable the fish to safely pass beyond the screens under gravity flow. The design of the gradient facility emulates naturally occurring riffles in the Sacramento River and enables recreational boating through this reach of the river. The crest of the gradient facility structure is as much as 4 feet above the degraded riverbed and dropped bottom of the river. The rock slope protection is supplemented by 3 sheet pile cutoff walls that extend beyond either riverbank to protect the gradient facility structure during major storm events. The buried sheet piles are surrounded and covered by rock slope protection and replanted vegetation. The rock slope protection extends 1,000 feet along the river channel and along about 2,500 feet of the levee banks, both upstream and downstream of the gradient facility. Access to this reach of the river was maintained throughout construction as the facility was constructed in phases, closing off only one half of the river at a time. This portion of the project was authorized by the Energy and Water Appropriations Act, cost $27 million, and had a cost-share program similar to that of the fish screen extension, 75% paid for by USACE, with the remaining 25% split evenly between the state and GCID. Although the fish screens and gradient facility benefit people, fish, and the environment, any construction in and along the river can result in environmental impacts. Environmental documentation prepared by participating agencies describe the potential environmental effects of project construction. A mitigation and monitoring plan prepared in conjunction with the environmental documentation specified mitigation actions for the project. Construction of the facilities affected elderberry plants and other riparian vegetation. Elderberry is a host plant to the threatened Valley Elderberry Longhorn Beetle, or VELB, and is critical to the beetle's long-term survival. To mitigate the impact, 211 elderberry transplants and more than 6,700 riparian associate seedlings were planted at 4 nearby sites along the river, totaling 29 acres. The selected sites are protected and thus will provide long-term productive habitat for the beetle and many other wildlife species. To demonstrate that the project has achieved its goal, the facility must pass certain tests, which were developed by the resource agencies and GCID. This testing program, the Fish Protection Evaluation and Monitoring Program, has 2 major components: biological and hydraulic monitoring to ensure that the fish are not jeopardized by the new facilities. This program is expected to conclude in 2005. Glenn-Colusa Irrigation District fully supports the restoration plans being developed for the anadromous fisheries within the Central Valley by both the U.S. Fish and Wildlife Service and the California Department of Fish and Game. This successfully implemented project is going a long way to meet 3 major objectives: to provide safe fish passage past the GCID diversion facilities, ensure a reliable water supply to GCID by allowing the district to divert their maximum capacity 3,000 cubic feet per second, and provide for long-term fishery protection of up to 50 years. According to GCID Board President Don Bransford, GCID is committed to obtaining lasting protection of anadromous fisheries at its diversions. The district's goal is to minimize the impact of its diversion on fish and wildlife while ensuring a reliable water supply to its farmers. The completion of the Fish Screen Improvement Project is a milestone in the district's history.